All right, today we're going to look at solving linear equations and solving inequalities. Okay, so in this first example, we just want to solve for m. The extra challenge is that we're dealing with fractions. I'm going to show you two different ways to deal with it. First of all, if you don't like fractions, which is understandable, you can multiply the entire equation by the denominator, right? And then you're canceling your denominator. So we're going to distribute that 4, the denominator, to every single term. So we'll have 4 plus 5m is equal to 1m minus 28. Okay, so just be careful. You multiply by 4 for every single term. Don't forget, one of them. So that's probably the easiest way to go about that. If you don't want to do that, you can of course deal with the fractions. So you can also, starting over, say, okay, I'm just gonna face this challenge and deal with fractions. So you can minus 1/4 m. And 5 over 4 minus 1 over 4 is equal to 4 over 4, which is 1. So you're left with 4 over 4 m and a negative 7. We can minus 1 to the other side. 4 over 4 is just 1. So we have 1m is equal to a negative 8, or m equals negative 8. If you multiplied both sides by 4, you're just solving for m as you normally would. So minus 4. So negative 32 is equal to 4m. Divide both sides by 4. We get m equals negative 8. So either way. Okay, next one. All right, this one's set up so that you can nicely distribute your fractions. Notice that your denominator is 3, and both 6 and 9 are divisible by 3. Here your denominator is 2, and both 10 and negative 2 are evenly divisible by 2. So that's nice. If you don't want to deal with fractions again, you could multiply by a common denominator right away. I'll show you both ways. So if we distribute 2/3 times 6. 6 we can write as 6 over 1. And remember, when we multiply fractions, we multiply straight across. Or you can think, okay, I'm going to cancel my 3's out of here, so I'm left with 2 and a 1. So I get 4. Okay, or you can multiply straight across. 2 times 6 is 12. Divided by 3 times 1. 12 divided by 3 is 4. Okay, so either way. So we've got 4x plus, so same idea. We've got 2/3 times 9 over 1 is equal to, and here we're going to multiply 1/2 times 10. Well, we know half of 10 is 5, and half of negative 2 is negative 1. Okay, this 2/3 times 9 over 1, we're going to cancel a 3 from both the numerator and the denominator. So 4x plus, now if we multiply straight across, we've got 6 over 1. So just 6 is equal to 5x minus 1. And then we'll just get all our x's on one side. So of x, we'll add 1 to this side. So move anything without x to the other side, and we get x equals 7. Okay, likewise, from the very beginning, just to show you another way to approach it. So again, it works out really nice that the denominators, our denominator is 3, and these numbers are divisible by 3. Here our denominator is 2, and these numbers are divisible by 2. So that's why distributing it is not a big deal. If it didn't work out that way, you could multiply by a common denominator. So a common denominator of 3 and 2 is 3 times 2, or 6. So if we multiply the whole thing by 6, we're going to cancel our 6 and our 3. So this 6 and 3 here, and that's going to give us 6 divided by 3 is 2. So we're really multiplying by 2. And on the other side of the equation, we're going to cancel our 6 and our 2. 6 divided by 2 is 3. So we're really multiplying that side by 3. If that makes sense. We don't distribute the 6 to every term because this is already multiplication here. This is already multiplication here. So we'll have 4 times 6x plus 9 is equal to 3 times 10x minus 2. And you can go from there, and you should get the same answer, x equals 7. Okay, so here's an example where, oh no, it works again. So same idea, look, we have a denominator of 2 and both of these terms are divisible by 2. We have a denominator of 5 and both of them are divisible by 5. So honestly, the easiest thing to do is probably just to distribute your fractions. Okay, so 5 over 2 times 2. So 5 over 2 times 2 over 1. Our 2's cancel, we're left with 5 over 1 or just 5. So we have 5c. We have 18 times our 5 over 2. So again, we can cancel a 2 from both our numerator and denominator. 5 times 9 is 45 over 1 times 1. So 45. Multiplying by 1/5 is the same as dividing by 5, right? So 25 times 1/5. 25 over 1 times 1 over 5, we're going to cancel, we're going to cancel a 5 from each of these, the numerator and denominator. So we get 5 times 1 over 1 times 1, or just 5. So multiplying by 1/5 is the same as dividing by 5. 25 divided by 5 is 5c, and 30 divided by 5 is 6. Okay, or you can multiply by 1/5. So 1/5 times 30 over 1, cancel a 5 from each one, and you're left with 6 times 1 over 1 times 1. So 6 over 1 is equal to 6. Okay, and then from there we're just solving our equation. 5 over 2, oh yeah, okay. Okay, so this is a unique one. Notice here, we're going to have our 5c's cancel. So we've got 0c, right? 5c minus 5c is equal to 0c. We can minus our 45 to the other side. So what is that? Negative 39? Okay. So basically 0c, and 0 times anything is just 0, right? So we're saying we've got 0 is equal to negative 39. But that's not true. We know 0 is not equal to negative 39. It's not equal. So there's no solution to this problem, because we got something that doesn't make sense. Okay? Okay, so no solution there. Next one, we've got 1 over 7. We have a denominator of 7. These are both divisible by 7, so it works perfectly to distribute. We've got a denominator of 6. These are both divisible by 6, so let's just distribute that. Okay, so 1/7 times 49. So it's like dividing by 7, right? Multiplying by 1/7 is the same as dividing by 7. So 49 divided by 7 is 7. Negative 14 divided by 7 is negative 2x. Okay, multiplying by a negative 1/6 is like dividing by negative 6. So 12 divided by negative 6 is negative 2x, and negative 42 divided by a negative 6 is positive 7. Okay, so we will add 2x to the other side, and something strange happens again. We have 0x, right? A negative 2x plus 2x gives us 0x. Plus 7 is equal to 7. Okay, now we can minus 7 from both sides. So 0 is equal to 0x. And remember, 0x, 0 times anything, is just going to be 0. So we've got 0 equals 0, which is true. 0 does equal 0. So what that means is there is an infinite number of solutions possible for this equation. Okay, so and they have to, it doesn't mean that every solution is possible. It just means there's not a set number of solutions that will work. There's an infinite number of solutions that will make this equation true. Okay, so let's look at some of those solutions. So 7 minus 2x equals a negative 2x plus 7. So for example, if it's easiest to look at it from this step, to be honest, if x equals 1, for example, so from that step, we'd have 7 minus 2 times 1. Does that equal negative 2 times 1 plus 7? So, so we get 7 minus 2. Does that equal, we're asking a question, does that equal negative 2 plus 7? Well, of course it does. 7 minus 2 is 5. Negative 2 plus 7 is 5. So when x equals 1 is a solution, you could plug in an infinite number of values. For example, you could plug in 2 for x, and you get 7 minus 4 and negative 4 plus 7. And of course they're equal, so 3, yes, is equal to 3. So notice there's not a set number of solutions. The number of solutions will go on infinitely. Okay, so if you get something like we got in this first example where 0 is equal to a number other than 0, that means there's no solution. Okay, so this is not the solution to your problem. The solution is that there is no solution, because 0 does not equal any number except 0. If you get that 0 is equal to 0, then you have an infinite number of solutions. So that means that x can be an infinite number of things. Okay, inequalities. We can solve these just like equations. The only thing we have to be conscious of is that when we multiply or divide both sides by a negative, it reverses the inequality sign. So this only happens if we multiply or divide by a negative number. Okay, by reversing the inequality sign, that means if it's greater than, it's going to go to less than if you divide or multiply by a negative. If it's less than, it's going to go to greater than. Okay, I'll show you what that looks like. Okay, so we're solving for t. We're solving this inequality. So right now we have a positive 3, so we're adding 3 essentially, so we can subtract 3 from both sides. It might be nice to multiply this negative 2 in to our binomial, so we have negative 8t plus 14 is greater than 5t, and then we have negative 2 minus 3, so minus 5. Okay, so from here, I'm gonna leave this t negative just to show you what's going to happen when we divide by a negative. You could, of course, add 8t to this side, but just to show you with the dividing by a negative, I'm going to subtract 5t to the other side. Okay, so we get negative 13t plus 14 is greater than negative 5. We can minus 14. So we have negative 13t is greater than a negative 19. So now if we have to divide by negative 13, right? So when we divide, both sides by a negative, we just have to reverse this sign. So we're dividing by a negative, so instead of greater than, we have t is less than 19 over 13, because we have negative over negative, that turns into positive, positive, right? So this is our solution. From this step, by the way, if we had simply added 8t to the other side, we get 14 is greater than 13t minus 5, right? And then we can add 5. So we get 19 is greater than t. Oh, sorry, 19 is greater than 13t. If you divide by a positive number, you don't change the sign. It's just like normal. So 19 over 13 is greater than t. And we always write our variable first, just because that's the way we communicate. We wouldn't say 19 over 13 is greater than t. We want to know what t is. So t is less than 19 over 13, right? If we read it this way, t is less than 19 over 13, so we write it that way. Okay, so that is our final solution. So either way, we're going to get t is less than 19 over 13. Okay, this one here, we can distribute our values right away. So we have negative 18h plus 42 is greater than or equal to 9 minus 18h. Okay. So we can add our negative 18h, or sorry, add our positive 18h. And something weird is going to happen. We're going to get 0h is plus 9. So 9 plus 0h. And that is less than or equal to 42. Okay, and then we can minus 9. So minus 9, 42 minus 9. Let's see, 12 minus 9 is 3, and we have 33. Okay, so 33 is greater than or equal to, remember 0h, 0 times anything is just 0. So is this statement true? 33 is greater than or equal to 0. Yes, 33 is definitely greater than 0. So this is true all of the time. So because of that, like the example we did where we get 0 equals 0, since this statement is true all of the time, that means there's an infinite number of solutions. Infinite number of solutions possible for this inequality. It's not like there's just one value of h that's going to make this true. Yeah. So, infinite number of solutions possible. Oh, by the way, this symbol is just a shorter way of saying that. So that fancy looking R stands for all real numbers, as you saw when we looked at sets. So it's another way of saying that. So all real numbers is the solution to this. So any number, so whatever you put in for h, as long as it's a real number, as long as it's a number that exists, it will give you a correct solution. Okay. So similarly, by the way, here. Yeah, all real numbers for this one is a much shorter way to write that. Okay. So you can write all real numbers are an infinite number of solutions possible. Okay, great. Thank you very much.